Back to my channel. Today's lesson is the second part of our tutorial on MANOVA. In the last video, or the first part of MANOVA, unfortunately around unit 23 the sound broke. So in this video we'll go over again the important of assumptions we need to check before computing MANOVA. The first assumption refers, or we can check it using the table function. This assumption, follow the rule of thumb. It's that the number of observations in each group, either Setosa, Versicolor, or Virginica, should be larger than the number of dependent variable. We have 3 dependent variable here. So in this case, this assumption is met. So 50 is more than 3, so we can assume this first assumption. The second assumption is also met, refers to independence of observations. Each subject here, for example, using the head function, downcase, head function, for example, iris. This, for example, each subject or each individual should belong to only one group. So there is no repeated measurement in our data. The third assumption refers to the absence of univariate outliers. We can check the univariate outliers using a sample box plot, and the multivariate outliers using the Mahal-Nobis distance. In our case, for multivariate outliers, we use Mahal-Nobis distance in our data set. No extreme outliers were detected, as shows this function of view to explore the results of Mahal-Nobis distance. The fourth one is, or the fourth assumptions is refers to Shapiro test or M-Shapiro test, is normality. Univariate normality used can be tested with Shapiro test Wilks, Shapiro underscore test from Rostatics package, and the multivariate normality using we can, for example, be tested using the M-Shapiro test. In this case, we have normality in distribution of all the dependent variable in each group, and also the multivariate normality is checked using the M-Shapiro test, and also the p-value is not significant, so we can assume the normality, whether univariate or multivariate normality of distribution. The fifth one refers to linearity and multicollinearity. We can check it using GG pairs function from GG Ali, as this figure shows the results of coefficient correlation of Pearson. All results is below now exceed the value of 0.9, and also we can assume the linearity following the scatter plot here. So multicollinearity correlations should not exceed 0.9. In our data set, Pearson correlation are all below 0.9, so we have no multicollinearity. If correlation here, for example, were above 0.9, we would need to remove 1 or 2 the highly correlated variables. So move on to check the homogeneity of covariance matrices using BoxM test. The BoxM test is very sensitive. The p-value alpha here is equal to 0.001. In our case, the p-value is very significant, less than 0.001. So we can conclude our assumption, or this assumption is violated. In this case, instead of Wilks Lambda test for MANOVA, we should use Pillai Trace, which is more robust in our case. So we cannot assume that the homogeneity of covariance matrices. The last assumption refers to homogeneity of variance. Homogeneity of variance using the Levin's test. First, we have detected that this assumption is violated. Used Levin's test. We have also concluded that there is no homogeneity of variance, and we solved the problem after transformation using log transformation of our 3 dependent variable, and we check it again. This is the results of the iris before this transformation, but after transformation, as this command shows, here, for example, iris 3, and here, this 3 command refers to the transformation of our 3 dependent variable using the log transformation, and after this we can check successfully iris equals 3. I will check it. So before transformation, after transformation, variables, variables. I think we could test the Levin's test. What's this? Yes. Now, but we should test each group. I think here. Variables. Iris 3. Sorry for this. So in this case, we can successfully check the homogeneity of variance using the Levin's test and group our data by variables. So this p-value after transformation, the results of or the value of 3 dependent variable, we have concluded that the p-value is more than 0.05, so we can assume the homogeneity of variance. After this, before computing MANOVA, here we first fit linear model using LM function, because MANOVA relies or depends on the linear model framework. Without this step, the results may be misleading. Then we compute MANOVA here. Very good. We can compute MANOVA using here Pillai and the Wilks test, Pillai Trace test. Since box M here is significant, box M here is significant, less than 0.001. So the MANOVA shows here a global, not significant, but a global significant difference between groups. P-value is equal to 2.2 multiplied by 10 by the power minus 16. But however, it does not tell us which dependent variable is responsible to this difference. So follow up this test, to identify which dependent variable of the 3 variables contribute to the global effect. We run univariate ANOVA here. Why univariate ANOVA? Because if the assumptions of normality and homogeneity are met, we use univariate one-way ANOVA. If the assumptions of for example, are violated of normality, we use instead ANOVA, we use the Cross-Wallis. And if we have a case or where the data is normally distributed and we have not a homogeneity of variance, we have an alternative, which is a Welch ANOVA test. So in our case, all the 3 here dependent variables show significant difference. The p-value is very less than 0.05. Next, we perform pairwise comparisons, and I called it this command pairwise. The results, so the results of 2K HSD2, we use 2K HSD, honestly significant difference, to identify which groups differ. So the results here show significant differences between all groups. Finally, to visualize the results with box plot or as a box plot or significant or elegant box plot ready to publish using ggplot2 and label here the data. Label should, for example, add the position XY position for pairwise, which refers to test pairwise comparisons. And also in this case we need to create a test label for the test. Here MANOVA test to get the results of MANOVA, which refers to a statistic. Here, the equal, for example, I will click to MANOVA, click to run the results of MANOVA. Here the F statistic is 60.39 and the p-value is less than 0.009, and parameter 6 refers to degree of freedoms, and 292 refers to the denominator degree of freedoms here, and then we use test also, and we add the position and we select or run the ggplot. I think there is no mistake here. I will check all this comment. The mistakes is here, variables like this. So this is that is the end of our presentation. This the box plot shows the distribution of each group. The blue line here, or the blue box plot here and here, refers to sepal width. The green one characteristics, or the box plot, refers to sepal length, and the red one is refers to petal length. Here the results of MANOVA of statistics, and the p-value is less than 0.000501. Sorry, the honestly significant difference is the pairwise test for comparisons between groups, and the Tukey for p adjusted between each group, and this line or characteristics to shows the which groups have a significant difference. So that's the end of our presentation on MANOVA. I hope this was helpful for you. If you have any questions, suggestions, please leave them in the comment below. Thank you for watching. Take care of yourself and peace out.